right? The next factor that we are going to look at is the activation energy. So recall in the energy changes, this activation energy is the minimum energy needed by the reactants for reaction to take place. So particles with energy higher than EA, then they can react, they knock together, they will not bounce off, the bonds will break and they will reform. Okay, so if I have a graph again, still a normal graph, and then my activation is here, only these particles will react. Okay, then I have catalysts. Okay, catalysts increase the speed of reaction by providing a alternative path with lower activation energy. Right, so this activation energy is an example of 500. Catalyst lowers the activation energy, so now if I have a reaction with a catalyst, now the reaction becomes 200 or the energy becomes 200. So now the reactants that have energy higher than 200 will be all this. Right, so with more reactants with energy higher than EA, there will be more effective collision, and this will increase the speed of reaction. Okay, so let's look at the explanation. Catalyst works by providing an alternative pathway with lower EA. So there is an increase in number of particles that possesses this lower activation energy, right? This red part, there's more of this red part, right, than the first one with the higher EA. Okay, this increases the frequency of effective collision. Please note that it doesn't increase the frequency of collision, just the effective ones. Okay, and it will lead to a faster rate of reaction. Okay, catalysts have these following characteristics. They speed up reaction, and I only need it in small amounts. Catalyst is specific to the action. It will only catalyze certain reactions. Specific, okay, those who learn bio, we know. For example, protein is digested by protease. And protease is the specific enzyme that can digest proteins. Right? Proteins cannot be digested by lipase. Lipase is used to digest fats, and that's what we mean by specific. Okay, catalysts remain unchanged at the end of your reaction. Okay, how do I know it is unchanged? Take a look at the mass. It will remain the same throughout the experiment. Okay, small amount of impurities may prevent the catalyst from working, and then we say that this is deactivated. In biology, we will say it is denatured. Okay, a catalyst increases the rate of reaction, not the U of chemical reaction. Okay, so when I add catalyst to a reaction, it does not produce more products. You will just produce the same amount of products at a faster rate. Okay, repeat myself. Catalyst does not produce more products. It produces same amount of product at a faster rate, so shorter time taken. And it's important, transition metals are often used as catalysts. Okay, so this explanation is my catalyst explanation. Remember, take note, it doesn't increase the frequency of collision, only the effective collision. And if I have an energy profile diagram, okay, this one is where I learned about energy changes, endothermic, exothermic, right? This is the energy profile diagram that I draw, right? A catalyzed reaction will be a lower harm. Okay, and then where's my activation energy? Is always from reactants to the top of the harm, right? So you can see the yellow part is the catalyzed part, and the green part, which is higher activation energy, is the uncatalyzed part. Same thing, the green part over here is the uncatalyzed part, and the yellow part is the catalyzed part of the reaction. Okay, enzymes is another word for catalyst. but these are what we call biological catalysts. Okay, so chemistry, chemical equations, chemical reactions, we use catalysts. If it's found inside the body, we say it's enzymes. Okay, enzymes are proteins in nature. Again, they are specific. They are denatured on heating. Low temperature, they are inactive, and then there's a best pH that you will work. Okay, and then uses of catalysts, these reactions we have to know. Okay, table process is forming ammonia. We will look at it in one of the chapters. Iron, my transition metal, is the catalyst. Okay, catalytic converters, this my rhodium and palladium is the catalyst. This one is learned in air and atmosphere where I convert harmful gases into harmless gases, like commonly existing gases, N2, CO2, H2O. Okay, and then last but not least, within the syllabus, we also have vegetable oil, which is actually fat. If I add hydrogen, it will be converted to margarine, which is solid fat. And the catalyst that I use is nickel catalyst. This one over here, this catalyst is in organic chem, which is the last big component of your Sec 4 work. Okay, this is ammonia formation, NH3, and this is in air and atmosphere.